This is part of the lecture for multivariable calculus, and in this video I'm going to talk about positions of lines and planes. So let's start with a plane. So I have this plane and I have a line. The line can be parallel to the plane like this. It can intersect the plane like that, so intersects, or the line can be exactly on the plane like this, so contain the plane. How we can check this? You just need to check the position of the normal vector n, the vector that is perpendicular to the plane, and the direction vector of the line. Okay, if L is orthogonal or perpendicular to n, then the line is parallel to the plane, or the line is contained in the plane. Otherwise, it intersects the plane. Okay, so let me give you one example. Where does this line x equals to -8 plus 12t, y equals to 1 plus 4t, and z equals to 7 minus t intersects the plane x plus 2y plus 4z equals to 6. Okay, to find this intersection point, all I need to do is to plug in the parameterization of the line. So if the line has any other forms like the symmetric equation of the line, you need to parameterize it, write the parameterization of that, and then plug in the parametric equation into the plane. Okay, so instead of x, I'm gonna put -8 plus 12t plus I have 2y. Instead of y, I'm gonna put the parameterization of the line for t plus 4. Instead of z, I put this parameter 7 minus t, and I'm gonna set this equal to 6. Why is that? It's just because for any t, I'm in different points in the line. For example, at t equals to 0, for example, I'm here. At t equals to 1, I'm here. At t equals to -10, I'm here. So it depends on the L and the point. At any different t, I'm in some part of the line. So to find exactly one point, I need to find the exact t where at that t the line and the plane intersects. Okay, so that's why I put parameterization of the line into the plane. So now I solve it and I get 12t plus 4t minus 4t, so I get 12t, and then I have -8 plus 2, which is -6, plus 27, 28, so I have plus 22, and it's equal to 6. That's why t is equal to -1. So the point, to find the exact point, I plug in -1 into the line, and I get -20, -3, and 8. Very good. Another example of this situation is to what is the relation between v, the vector v, which is 1 to -1, and x plus y plus 3z equals to 5. Okay, so I have a plane. This is a plane. So I have one plane in here with the normal vector n, and the normal vector, the components are coefficient of x, y, and z, and I have a vector. All I need to do is to check if they are parallel, the vector and the plane, or they are orthogonal or neither. Okay, so n, the vector n, would be 1, 2, 3, and I have a vector v that is 1, 2, negative 1. The cosine of theta, the angle between these two, if you remember the formula, would be n dot v over the length of n and the length of v. So I have 1, 2, 3 dot product with 1, 2, negative 1 over the length of n, 1 squared plus 2 squared plus 3 squared, 9, and I have 1 squared plus 2 squared plus negative 1 squared. So this is 0 because I get 1 plus 4 minus 3 equals 0. Oh, I made a mistake. I want this one to be equal to no, that was correct. I put n wrong, so n is 1, 1, and 3. So it's 1, 1, and 3. Just because I want, no, this is 1, 1, and 3. This is 1, 2, and then negative 1. Great. So the cosine theta would be 0, meaning that these n and v, so if this is n and v would be like that, therefore they are parallel. Perfect. Now let's talk about positions of two lines. Positions of two lines. So two lines, if I have 1 and 2 lines, they could be parallel, they could intersect like that, or they could be skew. What is a skew? I'm gonna tell you. So they could be parallel, they could intersect, and they could be skew. In the parallel and in the, if they intersect, there is a unique plane containing both lines. Okay, so I have a plane. If they are parallel like this, if they intersect, I can have a plane passing through them. But if they're skewed, it's not this situation. It means that I have two planes that contain both of each one of them. One of them would be this way, okay? The other one is this way. So they are like this. You see? I hope you can see it. One of them would be in this direction, and one of them would be in that direction. That's why I don't have a unique unique plane containing both. So they lie, in this situation, they lie in parallel planes. Okay, how can we check? You just need to check the direction vector for each one of them. Check direction vectors. If direction vectors of the two lines are parallel to each other, meaning that these two lines are parallel, if they intersect, you need to find a point that intersect the point of intersection, and also they are not parallel, but in the skew case they are not parallel to each other, and there is no intersection point on them. Okay, there is a video that I made about how to find that if two lines are skew lines. You can check that out. And also let's talk about positions of two planes. So two planes can be parallel to each other, or they can intersect in a line. Okay, and so two planes can be parallel. Let me show it to you. So I have this plane, which is 2x plus y equals to 1, and I have this plane, which is 200x plus 100y equals to 5. As you see, these two planes are parallel to each other. So planes are parallel when their normal vectors are parallel to each other. And the planes could intersect in a line. For example, these two planes. This is the plane z equals to 0. With another plane, as you see, they intersect in just one line. Okay, good. And now positions of three planes. So positions of three planes. So if you have three planes, they can be parallel, they can intersect in a line, or they can intersect in a point. That's interesting. Okay, can you think of a situation where the three planes intersect in a point? I'm gonna show it to you. Okay. I have this plane, I have that plane, and this plane. As you see, I have three planes. Z equals to 0. This plane 200x plus 100y plus 300z equals to 5, and the other plane. These three planes, as you see, they have just one intersection line. They intersect in a line. But if I make z equals to 0, y equals to 0, and x equals to 0 coordinate planes, they intersect in a point. Yeah, you see, they intersect in just one point, the origin. Okay, good. So these are all the positions that lines and planes are intersecting with each other. There are some videos that I make about how to find each of these situations, and you can check them out.